Hello everyone, myself Geeta. In this video, we are going to look into trigonometry. Trigonometry, it can be bifurcated. The terminology which we have, trigonometry, the term can be bifurcated into three actually, where tri refers to three and gon refers to angle. So totally trigon refers to three-cornered, which is a triangle they are meaning. It is a Latin word. From that only we got this meaning triangle. Okay. And then ometry means measurements. Together, trigonometry is a branch of mathematics which deals with the study of relationship between the sides and angles of a right angle triangle. So that is what the trigonometry is all about. So now let's look into like how the sides and angles relationship is getting formed. Let's have a look into that. Suppose I have a right angle triangle which is right angled at Q. Right angle triangle, I have a PQR which is right angled at Q. Then the angle, right angles side, opposite side, this particular angle which where right angle is getting formed, the side opposite to that is called as hypotenuse. And this particular side is always called as, the hypotenuse is always called as the longest side of a right angle triangle. Every time it is gonna be the longest side. And then now suppose I have a theta here. Theta is a variable which we use for angles. Like how we use x, y, z. The same way theta is used, theta, alpha, beta, gamma, we use for variables for angles. Now this theta is there. To this theta, the side which is opposite, that means this, the opposite one, QR, this is called as the opposite side. And for this theta, the side which is adjacent to it is called as an adjacent side. Suppose I'm considering some other angle. So let me consider some other angle. In that case, here I'm considering it as alpha. Then to this particular angle alpha, the side which is opposite to it, that is QP, that is gonna be my opposite side for alpha. I'm writing it with the color which I used for alpha. And for this alpha, the one which is gonna be adjacent is called as the adjacent side. Same way, let's go ahead and check with the other triangle. I have a triangle ABC here. Now here, for this triangle, which is gonna be the hypotenuse. So where it is right angled at, that's what I need to see. Right angled at C. So for right angled at C, the one which is opposite to that right angle is called as hypotenuse. The side which is opposite to that right angle is called as hypotenuse. Okay. And then let's look into the opposite side of theta. Suppose I have theta here. Okay, let's consider theta here. Let's change that angle as beta. Okay. Now, if I have a theta here, to this particular theta, which is gonna be the opposite side, this one, AC. So here it is gonna be the opposite side. Okay. And to this theta, the one which is adjacent is gonna be adjacent side. Okay. Now let's look into for beta, which is gonna be the opposite side. So beta is here. To that side, which is opposite facing to that particular angle, is gonna be the opposite side. And which is adjacent to this particular angle is beta angle is gonna be adjacent side. Hope you guys understood which is hypotenuse, which is adjacent, which is opposite. This, I think this much it is clear for you. Now let's look further deeper into this particular topic. So now here what we are gonna see next is I'm considering these three right angle triangle. Actually, how few things came into a picture regarding that only we are gonna speak now. So now I've taken a right angle triangle here, ABC. Triangle ABC I've considered, and I find that it is right angled at B, so angle B is equal to 90 degree has been said very clearly. Now, what they are gonna do is they are just verifying the ratio of certain sides. How they are doing is for the 60 degree, which is the opposite side. This one is gonna be the opposite side for 60 degree, and this is gonna be hypotenuse. So they had a check, just like that, the mathematicians, what they did, they had a check and they did like opposite by hypotenuse. In that case, we got 12 by 13.85. And the answer what they got was 0.86. And then they did this one, they observed 0.86. Now again they went and they checked for another triangle which also had a 60 degree, but their sides were of different lengths. So in this case, now let me consider triangle DEF, which is right angled at D is equal to 90 degree, and the 60 degree which we have, from that what is going to be the opposite side? This is going to be the opposite side, and this one is going to be the hypotenuse. And then what they did, again they took a ratio of opposite side by hypotenuse. And they were shocked because they got 0.86 again. Now they took another one. Here 60 degree we had, and for this also they took opposite by hypotenuse. So for this 60 degree which is gonna be opposite, and then which is gonna be hypotenuse. If this is 90 degree, the opposite side is gonna be hypotenuse. 60 opposite to it is gonna be opposite side. Then here also they took the ratios. So triangle X, Y, Z. So now in that case, it is going to be 6.92 divided by 8, which is equal to 0.86. So they observe the 60 degree, if any angle it is making in a triangle, then their opposite side by hypotenuse always remains 0.86. And they thought, okay, let's check for 30 degree also. And for 30 degree, they also, they have checked, they have checked opposite by hypotenuse. They got 0.5 for 30 degree every time. Even in this triangle, you can have a check opposite for 30. It is going to be 6.93 divided by hypotenuse. And here it is going to be 1 by 2, which you guys know it is going to be 0.5. And then here it is going to be 4 by 8, which is again 1 by 2, again 0.5. So what they observe, so for these sides ratios when they take opposite to that particular angle when they take that, so in that case their ratios came same value. They got the same value. So that was opposite by hypotenuse, and then even they tried with the adjacent by hypotenuse. So this is how they got the same ratios. Now what they did the next thing, they started plotting out everything for all the values. Just like that, they started plotting out. And they observed the sine formed a curve like this. I'm just marking 90 here, and then 180, and then 270, and then 360. I'm just marking a part of it, not the whole thing. They formed a, it formed a curve something like this. And here plus 1, here minus 1. For all the for all the values, the ratios, whatever they got, they just plotted it. And this curve looked just like the sound wave, which they have plotted, just like a sound wave. And then, so And the sound wave, we know very well how we call it as sinusoidal. And what they did, they took this name sine and they kept sine of angle, any angle, is gonna be equal to opposite side by hypotenuse. The same way, for a cos, they plotted it out and they got something like this. And they said cos theta is equal to adjacent side by hypotenuse. And then finally tan. Tan theta is nothing but the ratio of sine and cos, which is gonna be just a minute. Let me delete it. I don't know how it came. Okay, which is gonna be opposite by hypotenuse divided by adjacent by hypotenuse. Both hypotenuse gets cancelled. So tan theta, they came up with a formula opposite side by adjacent side. So this is how all of this came into a picture. So now let me just write down all the formulas for just recalling everything, whatever the formulas we learned. And with these formulas, we would be finding their reciprocal formulas also. So now here we have sine theta. Sine theta is equal to always opposite side by hypotenuse. And then cos theta is equal to adjacent side divided by hypotenuse. And tan theta is equal to opposite side by adjacent side. Okay, now let's look into their reciprocals. What will happen if I have 1 by sine theta? And one more thing, don't worry about all these graphs. This would be taken care completely when I am teaching trigonometrical graph. Trig graph when I'm handling, that time I will tell you very clearly what would happen with this graph. They are periodic. Regarding all these things, I would be speaking under the topic trigonometry graph. For now, we need all these basic things because based on that only we would be doing problems now. So that's the reason, the basic thing I have taught you. Now 1 by sine theta. What is 1 by sine theta? It is going to be 1 divided by opposite divided by hypotenuse. Where am I having, where exactly the hypotenuse is situated? It is situated in denominator's denominator. That means it is a numerator. So hypotenuse divided by opposite. So which we call it as, if it is a sine, then it is called cosecant theta. If I have yes here, the one which is getting introduced will start with C, cosecant. Okay, now when I have reciprocal of cos theta, which is gonna be 1 divided by adjacent divided by hypotenuse, which is equal to hypotenuse divided by adjacent. How we will call it? If I have something in C here, this side, 1 by cos, then it is gonna be secant theta. Okay, so whenever you are speaking about what is the reciprocal of sine, don't get confused with the cosecant or secant. When the sine is starting with S, then the reciprocal of sine would start with C, that is cosecant. And cos, the reciprocal of cos, if cos is starting with C, the reciprocal of cos will start with S, secant. Okay, and then we have now reciprocal of tan, which is 1 by tan theta. It's gonna be 1 divided by opposite side divided by adjacent. Adjacent, where exactly it is situated? It is situated in denominator, so it comes to the numerator. divided by opposite side, which is nothing but cot theta. Okay. So with this, all the ratios we have introduced. Okay, how to do problems based on this, we would be looking in the next video. And the shorts would be created for these things for formulae, opposite and opposite by hypotenuse regarding this for sine, for reciprocals and basic trigonometry, three formulas. And then even for angles, shorts would be there. Kindly have a check regarding that as well. Thank you.